With that, we'll start today's class, guys. Welcome, welcome. Oopsie daisy. So it's a continuation class, which means you should understand these concepts. I will revise them really quickly. But if you don't understand this, then Agika will be a little overwhelming. The next parts are overwhelming. Everything from deployment up to here is what we'll try to cover. I've run this in Super 30 twice. And even in the second time, I could see faces that were lost, specifically in this section. So everything until pods is easy. Deployments and replica sets, जो दो चीज़ें हम आज पढ़ने वाले हैं, the two things we're going to learn, are a little hard to digest, not too hard. So we'll see if we're able to digest them. Honestly, 2 hours is enough to understand all of this. But before we get there, I'll do a very quick Kubernetes 101. Okay, what exactly is Kubernetes? I can just go through the slides from last week. So yes, last week we tried to understand what is Kubernetes. It is mostly a jargon for a decent bunch of you. DevOps people use it. DevOps people, have some knowledge of Kubernetes, should understand Kubernetes internals, should deploy their applications using Kubernetes. But what exactly is Kubernetes? So mota it is something like this. It's a bunch of machines that will eventually run your backend containers, front-end containers, that will eventually run your full stack application. But usse pehle, they're actually running the Kubernetes code. So when you start a new Kubernetes cluster yourself, if you want to ever do that, usually you don't do that. You tell AWS, give me a 3-machine Kubernetes cluster or give me a 5-node Kubernetes cluster. You don't manually start it, but you can manually start it. And if you ever manually start it, the one thing that is running on this AWS machine one is the Kubernetes code. Same is true here, same is true here. Along with that, the Kubernetes code will help you execute your front-end containers, back-end containers, even databases for that matter, other auxiliary services, Redis, Kafka, things like these. So your Kubernetes cluster will be running a bunch of what are called pods. We'll come to what pods are. But long story short, if you are using Kubernetes, you are not going into an AWS machine, SSHing, pulling your code, installing Node.js and running it. You are simply telling the Kubernetes cluster, please run 2 or 3 backend containers, which means please run this Docker image thrice. It will start to run that Docker image thrice. Please run this front-end Docker image once from Docker Hub. It will start to run it. If you want to run MongoDB, just tell it कि यार ये MongoDB की image को run कर दो. Kubernetes is smart enough to find some space in one of these nodes and starts to run it. All of this is contained. Every pod that is starting, every container that is starting is has its own environment. जिसके अंदर it is sort of running. So one application can't really talk to another application. Networking in Kubernetes is a whole different concept we'll come to tomorrow. Today, we want to go beyond simple pods. So last week, we started with what is Kubernetes. How did you deploy applications before Kubernetes? I'm not going into this, but we have deployed many applications by this point. We understand virtual machines. We understand auto-scaling groups. We understand ECS. So some heavy deployment jargons we have been able to use. We've been able to deploy our applications on the internet. We have custom domains set up on them. We've also exposed them via HTTPS. After Kubernetes, this changes a little bit. This whole mindset of deploying your application manually is good to know for fundamentals, is also good to do for your first initial applications. But generally, Kubernetes is one of the best, if not the best approach to deploy your applications. Why do I say that? There are many reasons. Biggest reason is it's cloud native. It runs in any cloud provider. Most cloud providers that you see, Google Cloud Provider, GCP, AWS, DigitalOcean, Vultr, all of them support Kubernetes. And hence, if you ever want to move away from AWS to GCP, it's as simple as, it's just some commands that you have to run. That's not true for if you want to move from auto-scaling groups in AWS to MIGs in GCP. That's not true if you want to move from serverless Cloudflare workers to Lambda in AWS. But in Kubernetes, that is true because all of them are running the same things. When you start a Kubernetes cluster in Azure, you will get some machines where the Kubernetes code will be running. You can deploy your applications there. Same is true for AWS, same is true for GCP. That is why it's one of the best approaches, if not the best approach to deploy your application. There are other reasons. Kubernetes provides has 100 properties. It is self-healing. It has auto-scaling constructs. It has outside visibility, networking. You can protect a few applications. You can open a few applications to the internet. Those are there. But why would a company that is not using Kubernetes want to move here? One of the reasons is cost optimization, moving across multiple clouds, resiliency across clouds. You can have a Kubernetes cluster that is half running in GCP, half running in AWS, half running in Azure. That way, if GCP is ever down, your cluster is still always up. You can always, you have resiliency. Your users can visit your application. So those are the reasons you might want to move here. The architecture of Kubernetes is a little hard to digest, but mota. Whenever you start a Kubernetes cluster, you are starting one master node. I repeat, you can start multiple, but generally you're starting one master node and multiple worker nodes. What is a node? A virtual machine, an Ubuntu machine that is running. But the Ubuntu machine is running your Kubernetes key binary. So whatever Kubernetes binary you can export from GitHub, you're running over here, running over here, running over here, running over here. When you start the binary here, you tell it you are a master, and you tell these guys you are worker nodes. Each one of them, you give each other's IP, so they can all discover each other. They all understand that they are part of the same Kubernetes cluster. You don't ever have to do any of this. You go to AWS, you say, give me a 4-node machine. It starts a 4-node machine for you, or a 4-node cluster for you. One master node, multiple worker nodes. Once this Kubernetes cluster has started, you, the developer, interact with the master node. इसकी IP आपको मिलती है. Let's say the IP is 22.45.33.11. You interact with this master node. You tell it, please start my backend image from hub.docker.com. Please start one front-end image from hub.docker.com. You don't specify what node to start it on. You can, if you want, this specific pod should run on a specific node. But generally, you don't really care. You just tell it, 3 backend node, 1 front-end node, chala do please. 3 backend pods or images, 1 front-end image, please start. And then the master nodes somehow schedules, these 2 I will send over here, this one I will send over here, front-end I will send over here. That's how you start pods. They are not visible to the external world. Even though I have an arrow over here, this is how you will interact with the cluster. We haven't learned this yet. We have only learned how to start containers. They're sort of useless because you can't really access them from the internet, but they're running. So for applications that you don't want to expose on the internet, maybe the machine learning model being trained. When a machine learning model is being trained, you don't really need to hit an API and talk to it. When a video is being transcoded from 1080p to 720p, it's a 1-hour process, but that 1-hour process can run independently here. It doesn't need to be exposed over the internet. So for those cases, you start what's called a pod. Thoda jargon hai. Nodes, each one of these is called a node. Cluster, all of them together are called a Kubernetes cluster. So this is a 4-node Kubernetes cluster, 1 master node, multiple worker nodes. Images we already understand, same as Docker images. hub.docker.com/_/mongo is the MongoDB image that someone has posted on Docker Hub. Similarly, you might have your own custom images. These are what are called, the Docker concept we already understand. Containers also we understand. Not a Docker concept, a more generic concept, but we have learned them when we were learning Docker. Okay, whenever you are starting an image, that's what's called a container. एक नया jargon आया है बस, pod. Pod is a Kubernetes specific jargon. These aren't. Nodes and clusters are sort of being used in Kubernetes ki context here, but nodes is a more generic thing, right? You start a machine, you start a node. A bunch of machines is what's called a cluster. Images and containers, so purely, container jargon, not really Kubernetes jargon. But pods are specific to Kubernetes. When you start something, you are not starting a container. You are not telling it, please start MongoDB container. You tell it, start a pod which is running the MongoDB container. A pod can run multiple containers. तो एक pod में आप 4 container भी चला सकते हो. You can start backend and frontend in the same pod. That is not usually done. Rarely do you start multiple containers in a same pod. एक pod के अंदर usually एक container होता है. Whenever you are talking to the master node, you tell it, start one backend pod which is running the backend container. Start 2 front-end pods which are running the front-end containers. That's how you would usually start an application. If you want, one pod can start multiple containers. Someone asked last week कि हरकीरत, then what is the need of a pod? Containers ही क्यों नहीं start कर देते? It's a higher level abstraction कि अगर आपको Kubernetes use करना है, you can't just tell it कि यार start one container. You tell it start one pod which is running one container. That is fine. Even if you want the pod to run a single container, आपको उसको pod ही बताना पड़ेगा कि यार एक pod बना दे प्लीज. Kubernetes doesn't understand कि container start कर. Kubernetes understands pod start करो, जिसके अंदर आपको एक container start करना है एक करो, 10 करना है 10 करो. You can also start multiple pods. For example, here I feel like my backend load might be really high. So I have 3 backend pods running and 1 front-end pod running. These pods share resources on the machine. So if this is my AWS machine 1, which has 2 GB RAM, 4 CPUs, it's being shared amongst them. If this starts to starve, so these applications are the same, so it doesn't really matter. But if it happens, we have a lot of backend load going over here, it will start to starve the other process. दूसरी process run ही नहीं हो पाएगी. If frontend and backend were on the same node, दो ही pods होते मान लो, we only had 2 pods running on the same node. If one of them was starving the application, the other one will actually not be able to respond. This is where you can add resource limits. You can say that this pod should take at max 1 CPU and at max 2 GB RAM, so that if it's ever scheduled on a node, it doesn't eat the complete node. So it's common practice to add resource limits also and resource minimums also. I repeat, resource limits. कि यार ये pod maximum 1 GB RAM ले सकता है, 2 CPU space ले सकता है. Resource के minimums क्या कह रहा हूं मैं? If I say कि this pod, I'm not saying this pod has to take 1 CPU and has to take 2 GB. When you talk about resource constraints or resource minimums जो मैं कह रहा हूं, you basically mean to say कि यार अगर ये 2 GB की मशीन है ना, if this is a 2 GB machine with 4 CPUs, this backend pod ऐसे, चलो छोड़ो, let's not go there. Resource constraints पे आ जाएंगे. We'll come to resource constraints when we come to. Let's not complicate this even further. I'm going down a rabbit hole I shouldn't. तो अभी तक we understood कि there is one very cool thing in Kubernetes called pods. Cluster, nodes and pods. इसको छोड़ के we discussed the architecture of Kubernetes. I'm not going into it right now. We can dive deeper, but each one of these machines is running nothing but some Kubernetes code. So what is that code? What code is it running? What is this API server that the user interacts with? How does the developer interact with the cluster? Is all we have discussed last week. ठीक है. Then we started a Kubernetes cluster locally. Yeah, I would recommend you do today as well, because today also we're doing a few things. So let's do a little bit of practical. Let's run a Kubernetes cluster locally. Hopefully you guys understand this. I might already be running it. I am already running it. But for the people who are coming for the first time, there are 2 ways you can start Kubernetes locally. There is Minikube and there is Kind. These are 2. Think of them as libraries, services, whatever, that let you start Kubernetes locally. So if you want to test it for free, you don't want to get a Kubernetes cluster from AWS, you should use one of these. The one that we used last week was Kind. So if you, there are installation steps here. Let me put this in the chat. But if you haven't already done this, I would urge you to quickly do it, because most people, at least last week, were able to run a Kubernetes cluster locally. Let me run one again. Let me delete the cluster that I have locally. And let me start a Kubernetes cluster locally. There are, all the steps are here, especially if you have Kind. But ignore step 1, ignore step 2, ignore all of them. This multi-node setup is what we have to do. We have discussed what the above points are last week, so you can go to last week's video. But basically, if you follow these steps, it will start a single node setup, which means you will have a single node on your machine, which will be the worker also, which will be the master also. That's bad. You should have a separate master node, separate worker nodes. Master nodes shouldn't be scheduling pods, or shouldn't be running pods. Pods should be running in a worker node 1, worker node 2, like that. So the multi-node setup will do what? It will ask you to specify a configuration कि बता दो भाई कैसा cluster start करना है locally. And we can specify कि यार we want a 3 node setup one control plane, which means one master node. Master node is also called the control plane. Two worker nodes. इससे क्या होगा, हमारे 3 नोड स्टार्ट हो जाएंगे. Now of course I am not actually starting 3 Ubuntu machines inside my Mac machine. They're just virtual nodes for now, just for local testing. It's not like I've been able to start 3 machines that are running Kubernetes. So step 1, create a clusters.yaml file. I already have it, but I would urge you to create this clusters.yaml file locally and then run kind, which stands for Kubernetes inside Docker. So you need to have Docker in your machine for kind to run. Kind create cluster. This is the configuration file using which the cluster will be created. And this is the name of the cluster, which is local for now. You can call it whatever you want. If you run this command, it will start a Kubernetes cluster locally on your machine. तो ये तो step 1 type ही है. Just like we install Node.js in our machine to run Node.js applications, Java, JVM to run Java applications, the Rust compiler to run Rust applications. We have installed kind, which stands for Kubernetes inside Docker. We have created a 3-node virtual Kubernetes cluster. It doesn't really make too much sense. It's not actual nodes that are running something. Local testing के लिए great. It starts all the Kubernetes components locally. After this is done, I can do a kubectl get nodes. So here you need to have another command line interface locally. One of them is kind. I already have kind locally. Hopefully some of you do as well. The other one was kubectl. Kubectl get nodes is the first command that we're learning today. We have already learned, I'm just recapping. Kubectl get nodes gives you, I am currently connected to a 3-node Kubernetes cluster, local one. I also have some on DigitalOcean. So, you will eventually create a Kubernetes cluster in DigitalOcean and connect to that DigitalOcean Kubernetes cluster. So if I go here, I quickly log in. You will see I have I think 2 Kubernetes clusters over here. If you look at first project, you will see there is a section called clusters where I have Kubernetes cluster 1, Kubernetes cluster 2. This one was started 6 months ago. This one is for this is where app.100xdevs.com runs. This is where projects.100xdevs.com runs. So if I open this, you will see it's a 3-node setup, very similar to the setup we have locally. So यहाँ पे I actually have 3 nodes running on DigitalOcean. If I click on resources, I can see I have a node pool which has 3 nodes. So if I want, I can connect my local kubectl to DigitalOcean as well. If I go to DigitalOcean and click on overview, click on verify connectivity or connecting to Kubernetes, I can download. You don't have to do all of that. I'm just showing you. I can download a configuration file. I see it over here. This is like my password to my Kubernetes cluster. If I move this configuration file, this password file to .kube/config, I already have it locally. So if I do a copy .cube/DigitalOcean to .cube/config, then I will be able to connect to the DigitalOcean Kubernetes cluster. So this is the place where your Kubernetes configuration file is present. In your root folder, there is another folder called .cube, जिसके अंदर there is a file called config. Now, if in the future you start a DigitalOcean Kubernetes cluster, you will download the configuration file. You will place it over here. Right now, we are running it locally. How did I start Kubernetes right now? I started it by running kind create cluster local and -- name local. When you run this command, automatically this file gets updated. Kind puts the credentials of your local cluster over here. So this is the file that holds the credentials that let you connect to a cluster. the endpoint where the cluster is currently running, the master node का जो API endpoint है, all of that is present in this file. You guys can actually see it. You can do a cat.cube -config, and you will, if you print this file, you'll see a very big configuration file. This configuration file is what has the credentials that are forwarded to the Kubernetes cluster when you run these commands. When I run kubectl get nodes, what is happening is a HTTP request is going out to some endpoint, which is my master node endpoint /API/v1/nodes. There is just an HTTP request that goes here. If I send that HTTP request in the browser, तब तो मेरे पास कोई nodes वापस नहीं आते हैं. It says nodes is forbidden because anonymous user can't access nodes. I have not passed my configuration file over here. But अगर मैं locally kubectl get nodes run करता हूँ in my terminal, तो the credentials are picked from here and forwarded in the request. तो ये request जो जा रही है, इसमें headers में कहीं पे we are passing my Kubernetes credentials. Hence, I'm able to talk to my cluster. So if I do a k get nodes, I see this. For my machine, k is an alias for kubectl. You can do that as well. You can write alias k equal to kubectl. If you run this command, then you can just write k. It will give you the same thing as kubectl. This is the command to do that. So if I do a k get nodes, I see I have 3 nodes running. One of them is the master node. 2 of them are worker nodes. The status of all 3 of them is ready. The question from here that we tackled last week was, how do you start a pod? Which is very important before we move to the next section. Pod को कैसे start करें? पहले let's do a quick check. Are we good to go? यहाँ तक सबको सब समझ आया? ये तो last week का recap ही था वैसे. But do we understand everything until this point? Can we proceed to now first creating pods, and then from there we'll create what are called replica sets. From there we will create what are called deployments. So do we understand everything up until this point? Let's do a poll. I'll look at Q&A until then. Okie dokie, you are right. That is why there was a lag. I was connected to the VPN. Alrighty, beautiful. While using kind locally, are we running each node as a Docker container? So while production does each node refer to each VM, we don't use kind in production. In fact, last week someone said this, Harkirat, we are using kind, which is running all of our nodes as Docker containers. Yes, which is running the eventual pods, which are also running Docker containers. So sort of you are running Docker containers inside Docker containers, and that is sort of true. This is only for testing purposes. You don't use this in production. Alrighty. Now comes the question of how do you start a pod. So we discussed 2 approaches last week. One of them is you simply run something like this. Sorry, this is Docker. You do a kubectl run nginx image and port. So what does this command do? This will start a pod with the name nginx. उसका नाम nginx होगा. Image name ये नहीं है. This is the name. I can call it whatever I want. I can call it nginx Harkirat. This is जो मैं नाम उसको देना चाहता हूँ pod को. Image is कि Docker Hub पे ये किस नाम से present है. What name does it have on Docker Hub? So if I select nginx here, that means I'm going to run hub.docker.com/_/nginx. If I select Mongo, then this Mongo image will run. So if I do --image equal to Mongo, तो MongoDB image का pod start हो जाएगा. A pod will start which has one image, MongoDB. What are we starting? Nginx. And then what port is exposed? For MongoDB, it's 543. No, it's not 543. What's the MongoDB default port? 27017. For these guys, it's the default nginx image runs on port 80. So if I run this, it says, oh, I can't use an underscore here. So let me do nginx Harkirat. So it says pod nginx Harkirat created. Matlab, in my Kubernetes cluster now, I have a pod running. I have one pod running on one of these worker machines. मेरे पास 2 worker machines थी, एक पे pod चल गया है. How can I confirm? I can do a kubectl get pods. If I do kubectl get pods, it returns me कितने pods अभी चल रहे हैं. अभी एक ही चल रहा है. I can start another one. Let me do kubectl run nginx harkirath 2. Now if I do kubectl get pods, it shows me 2 चल रहे हैं. One of them is running. One of them is starting to be created right now. If I run it again, you will see the second one is also running. This started 46 seconds ago. This started 9 seconds ago. So you can start, I mean, theoretically as many pods as you want, but of course there are limits, right? If you're only on a 3 node cluster like I am, that too on my Mac machine, if I start 1,000 pods, it will fail. Most of the pods will be stuck on starting. They will not be able to start. Only 3, 4, 5, 10 will start. So theoretically you can do whatever you want. You can start as many pods, but theoretically you can go to a virtual machine and start 1,000 Node.js processes. But at some point there will be resource limitations, right? You'll not get enough ports. You'll not be able to start enough processes. The same is true over here. I have 2 pods. They are running klogs-f nginx harkirath. I can see the logs. I can tail the logs. -f means follow. So I'm following all the logs from this first pod. Beautiful. I can see कि कुछ इसमें चल रहा है. If this was my custom application, then I would have seen my own custom, backend logs, frontend logs, so on and so forth. So they are running for sure. They are not accessible. I can't talk to them, but they are running. Kget pods gives me the name of both the pods. Kdescribe pod, name of the pod, will give me a bunch of details about the pod. kubectl describe pod, the name of the pod is telling me कि ये जो इस specific pod का नाम ये है, the name is this. Namespace is default. Harkirath, what are namespaces? We'll come to eventually. It's a Kubernetes specific concept again. When was it started? Node local worker / this thing. Amongst what 3 nodes did I have? If I do a docker ps, you will see I have see there's a bed. There you go. Local control plane, local worker 2. So I have, if I do a docker ps, I have 3 containers with names: master node, worker node 2, worker node 1. When I did a kubectl describe nginx harkirath, it told me कि यार nginx harkirath pod जो है, ये वाला जो pod है nginx harkirath pod, it told me where it is running. It is running on local worker, which means this specific node. What about the other one? If I do a kubectl describe pod nginx harkirath 2, where is it running? It's running on local worker 2. So is Kubernetes doing its job? Is it scheduling one on worker 1, one on worker 2? Yes, Harkirath. So that's how you can dive deeper into what exactly is happening inside the pod. You describe a pod whenever it's not starting. Eventually we'll see when a specific pod is not able to start. You can read through these events and see where exactly is it stuck. Why is it not being able to schedule? Cool. ठीक है. Now we have 2 pods. I can delete the pods as well. So kubectl delete pod nginx harkirath, kubectl delete pod nginx harkirath 2. I am back to an empty Kubernetes cluster. ये सबको समझ आ रहा है? Starting a pod, which means starting a Node.js application. If you want to start a MongoDB pod, then all you have to do is kubectl run name of the pod. You can call it whatever you want. Let's say Mongo. And select the specific image that you want to start, which will be Mongo. For those of you who are thinking कि हरकीरत अगर pod बंद हो गया तो data loss हो जाएगा, the answer is yes. Just like if I do a docker run Mongo, something like this, and then I close the container, I stop the container, the data gets lost. Do you remember the concept of volumes in Docker? Docker may be introduced volumes to add persistence to MongoDB containers, to Postgres containers. Same is true for Kubernetes. If you're ever starting a stateful container, you're starting a pod which is running Postgres or MongoDB or Redis or Kafka, then you should attach something to the pod, which is a concept we'll come to eventually, persistent volumes. Abhi ke liye, if I start Mongo, it might start. I will put some data there, but if it crashes by default, by mistake, Whenever I restart it, the data will be lost. ठीक है? So that is about pods. Do we understand pods? Because इसके बाद what we're learning is, a concept on top of pods. This was the first checkpoint, which is we understand clusters, nodes, images, containers, and pods. One small call out here is that usually you shouldn't start pods like this. In fact, you should never run naked kubectl commands like this for posting data. You can run it for getting data. You can run kget pods whenever you want, kget nodes, whatever you want to run. That's fine. Fetching data, fine. When you are applying something, when you are creating a resource, then you shouldn't create it like this. You should put it in a file. You should create a file that has the resource you want to create. What is the resource we want to create? We want to create a pod. That is what this guy created. Put that in a file. This file can have version control. File can be committed to GitHub. File is there on your machine at the very least. So you can always, come back and see kya hua tha. Always apply these files, which are called manifest files. Rarely, if at all, should you run kubectl commands like this to, create a resource in Kubernetes. So if you look at this manifest, what is it saying? It says API version v1, which means कि आप जो चलाने की कोशिश कर रहे हो, you are trying to start a pod. Kind pod means कि I want to start a pod. Eventually, we'll see more things. Services, deployments, replica sets, config maps, secrets, so on and so forth, persistent volume claims. ये kind बहुत चीजें आएंगी आगे जाके. अभी के लिए we have only learnt about pod. Pod was introduced in the Kubernetes API version v1 and hence we have selected API version v1. कल को we might have a different kind of resource we create which does something. उसके लिए the version might be different. For pods, the version was v1. That's what the first two lines mean. Then there is some metadata. You can add more metadata here. The most common one is name, क्योंकि कुछ तो name होना चाहिए आपके pod का. Whatever name you pass over here will be the name of your pod, similar to this thing right here. तो यहाँ पे the name was Nginx. यहाँ पे you define the name in the metadata section. So this is the name of your pod. And finally, the specification. Specification has containers, which is an array. Right now we have a single container. If we want, we can start multiple containers in the same pod. But this is the single container. This is the name of the container, not the pod. This is the name of the pod. This is the name of the container number 1. If I add another container below, I can give it a name as well, so on and so forth. Name of the container, image that we're starting, hub.docker.com/nginx, and what ports are open on this specific pod. This does nothing. Opening the ports does nothing. You still can't access it, but you're just telling कि हाँ इसके port 80 पे कुछ चल रहा है. तो if I copy this and create a manifest.yaml locally, I've created a manifest.yaml locally, which is exactly the same. I can run kubectl apply -f manifest.yaml. What does this do? It applies the manifest, which means it's basically doing the same thing as this command. It's doing the same thing as this command, but it's written in a file. So I can always read it. I can open it. I can edit the file. I can reapply. So always create manifest files. Rarely, if at all, run commands like these to post resources to the Kubernetes cluster. You can get as many resources you want using kubectl. When you're applying a manifest file. Cool. If I do a kget pods, you will see the pod is running. The pod is running, even though I never ran this command. I just pasted the command, never ran it. Why is the pod running? Because I have applied the manifest and it says pod nginx created. If I reapply the manifest, what will happen here? Another pod will be created. No, it says pod unchanged. It knows कि यार इस नाम की तो एक already चल रही है. If you look at it, metadata name nginx is already running. So if I reapply the manifest, it says unchanged. आपने कुछ change ही नहीं किया. So I haven't really created a new resource. I haven't deleted a resource. I have just done nothing basically. It's clearly telling you that nothing changed because nothing changed over here. If you change the image, change ports, some of these things you can change, some of these things you can't change. So whatever you can change, उसको change करो, reapply करो, वो change हो जाएगा. If you want to do something very specific, I think if you want to add another port here, then you can't just change it. Kubernetes won't let you. So you will have to delete the resource. So k delete pod nginx. Delete हो जाएगा. I will update the manifest.yaml. I want to introduce another port over here. Let's say 443. and then I can reapply the manifest. So as simple as that. ठीक है? So this is where we were last week. It's 8:40. So we have spent 40 minutes until the last week. This is a checkpoint. Now we have to learn about the second Kubernetes resource in our journey. We have understood one Kubernetes resource, which is a pod. Today we have to learn about replica sets and deployments. This order is incorrect. First, we will understand about replica sets, then we will come to deployment. Before that, a quick poll also. Sorry for the people who just joined. The class was supposed to be at 8 only. We scheduled it incorrectly. But thankfully, अभी तक मैंने सिर्फ recap किया है. Now we're starting the actual class. So if you are up to date until last week, you should be fine beyond this point. Quick poll. Do we understand everything until this checkpoint, which is clusters, nodes, images, containers, and pods? Do we have it running locally? That would be good. If not, that's fine. You can go back to the class. Do we understand everything until this point? Let's do a poll. All right, 88%. Good. So now we're going to learn about replica sets. These are called API resources or Kubernetes objects. अलग-अलग नाम होते हैं इनके. Pod is one of them. The second one is that we're learning about is replica sets. Name is giving it away. Replica set. A replica set in Kubernetes is a controller that ensures a specified number of pod replicas are running at any given time. A few things over here. It is a controller. What is a controller, Harkirat? Remember from last week? A controller, also known as a control loop, is an infinitely running loop that is always checking something. It's doing something every 1 millisecond. ये हुआ क्या? नहीं हुआ, हो गया, नहीं हुआ, हो गया, नहीं हुआ. Infinitely चलती रहती है. One such control loop, one such controller is the replica set controller that ensures a specified number of pod replicas are running any given time. अगर आपको एक एप्लीकेशन में 2 pod start करने हैं, if you want to start 2 pods of your backend container, 2 pods of Nginx, 2 pods of MongoDB, you can start them manually. You can be like, यार मैंने एक manifest.yaml तो बनाई थी. Let me, you can put more resources here. So what I will do is I will add another resource here, Nginx 2. And now this will create 2 pods which are starting the same image, right? Image तो Nginx ही है दोनों जगह जो start हो रही है. The name of the first pod is Nginx. Name of the second pod is Nginx 2. So you can do this manually. You don't need replica sets. Try करते हैं इसे. अभी के लिए how many pods am I running? I am running 1 pod. Let me delete it. I have deleted the Nginx pod. Let's look at the manifest.yaml. Manifest.yaml में I have 1 pod defined over here. Then I have a comment. Then I have another pod defined over here. First pod का name is Nginx. Second pod का name is Nginx 2. Why am I doing this? Because I feel Nginx is going to be a very heavy application. A lot of people are going to visit it. तो मुझे 2 pod चलाने हैं इसके. If I apply the manifest, it says pod Nginx created. Why does it not start the second one? Why did it not start the second one? Let me put this in a separate file. वैसे तो it should have manifest2.yaml. I'm sure I'm missing something very obvious. You can do that. You can start 2 pods in the same manifest file or multiple resources in the same manifest file. I'm missing something obvious. I'm sure some of you already know in chat. But how many pods do I have right now? Nothing. I have a manifest.yaml file which has the first pod ka code. I have the manifest2.yaml file which has the second pod ka code. दोनों में फर्क क्या है? The only difference is the name of the first one is Nginx. Name of the second one is Nginx 2. If I apply the first manifest, k apply -f manifest, it says pod Nginx created. Let me apply the second one, manifest2.yaml. It says pod Nginx 2 created. If I do a k get pods, I see 2 pods are running. So why do you need a replica set, Harkirat? A replica set in Kubernetes is a controller that ensures a specified number of pods are running at any given time. अगर मुझे 2 pod चलाने हैं, मैं ऐसे चला सकता हूँ. I can create 5 files, I can apply them, I have 5 pods running. But they will not always be 5. अगर गलती से this guy crashes, if Nginx crashes for whatever reason, or Nginx 2 crashes for whatever reason, they will not restart. They will not auto heal, which is one of the properties of Kubernetes. Kubernetes said, if your pod crashed for whatever reason, if Nginx 2 crashed, I will restart it. I sort of simulated a crash, even though I deleted it. So that makes sense. Delete karna chahte ho to delete hi karna chahte ho. It shouldn't restart. But let's say it crashed. If it crashed, then it will never restart. You will still see one pod over here. That is bad. This is where replica sets come. It ensures that a specified number of pod replicas are running at any given time. अगर एक crash होता है, वो restart हो जाएगा. उसे बता दो कितने replica चलाने हैं. The answer could be 2, 5, 20. And you don't have to specify 20 different manifests. आपको 20 अलग-अलग फाइल क्रिएट करने की जरूरत नहीं है. One file which creates not a pod, it creates a replica set. Replica set को बता दो 20 बनाने हैं, 20 वो बना देगा. It is used to maintain a stable set of replica pods running in a cluster, even if some pods fail or are deleted. अगर आपने delete भी कर दिया ना 2 pod, फिर से चला देगा. Replica set's job is to make sure if you tell it कि 5 pod चलाने हैं, तो 5 pod चलेंगे. If you delete 2 of them, it will restart them. If you delete 3 of them, it will restart them. If you delete all of them, restart them. Unless you scale it down to 0, बार बार उनको वो 5 करता रहेगा. In fact, if you start a 6th one, it will turn 1 down also. It will bring it back to 5. So its job is to make sure only X number of pods are running. When you create ignore this line of code. So we have not learnt about deployments yet. So it will be hard for us to understand this or even this. So ignore these two for now. Ignore this as well. Let's go to the next slide and let's try to create a replica set. Creating a replica set. Slide number 14. अभी हमने deployment नहीं करी है. That is why I have skipped a few files. I have skipped this deployment. Series of events also I have skipped. Create a replica set पे आ जाते हैं. Let's try to see. Rather than writing 20 different files for 20 different pods, can I create a single file and just have this replica number set to 20? और क्या मेरे 20 pods start हो जाएंगे? Will 20 pods start for me? Let's see. Let's try to read through it again. Notice API version apps/v1. So we are creating another Kubernetes resource. Just like we had created pods over here. API version v1 kind pod. Are we starting a pod now? No, we are starting API version not v1 apps/v1 kind not pod replica set. Because हम क्या start कर रहे हैं अब replica set. Replica set will automatically start pods. We don't have to worry about starting the pods. वो job है replica set controller की. The replica set controller that's running on the master node will ensure always 3 number of pods are running. Give a name to your replica set. This is not the name for your pod. This is the name for your replica set resource. As I said, these are called Kubernetes resources. Pod is a resource. Replica set is the second resource that we're learning about. Specification. This will define कि क्या start करना है. Specification says कि I want to start 3 replicas. ये थोड़ा सा hard होगा. What is the selector section? What is the template section? ये और ये क्या कर रहा है? Let's start with the template section. तो I want to start a replica set. This is the name of my replica set. This is the specification of my replica set. मुझे 3 replicas start करने हैं. But what is this selectors section? And what is this template section? Template section is कि हमें क्या start करना है. What is the one container I want to start? Of course, I want to start 3. पर वो कैसा दिखता है? उनमें से एक कैसा दिखता है? What does one pod look like? So the template says कि यार जो pod start हो रहा है ना, the pod that is starting is going to have this label, app nginx. It is going to have this label. What is the label? It's just multiple key value pairs you can add. कि app nginx, developer Harkirat, team backend, I don't know, environment production, environment dev, so on and so forth. You can add multiple labels over here. हम सिर्फ एक लेबल डाल रहे हैं कि यार इस स्पेसिफिक पॉड में एक ऐप लेबल होगा जिसका नाम है nginx. The app is called nginx. You can call it whatever name. Harkirat also you can write. Harkirat you can also write. We are just saying that this is one label, only one label that we want to attach to the pod that is starting. जो pod start हो रहा है, जो भी ये replica set pod start करेगा, that pod should have app set to nginx as the label. Label क्या है? Nothing. It's just text. For this pod there is one label which is app nginx. Label क्या होता है? Watch. This is a watch which has a label Titan written on it, right? Similarly, a pod has a label on it. Specification of the pod. कि pod में कितने containers चलने चाहिए? Only one container. With this is the name of the container. This is the image that we need to start it on. These are the ports. Now, of course, name cannot stay nginx. अगर 20 start हो रहे हैं, if this is 3 or this is 20, they will not all have the same name, nginx. So you will see the final name become something like nginx 1 or nginx random id 1, nginx random id 2, so on and so forth. हम बस एक prefix दे रहे हैं सारे pods का कि all the pods should start with a name that looks like this, nginx dash something. The pods will not all have the name nginx. It will have some customized name. Image that we are starting, hub.docker.com/nginx and the port mapping over here. That's the template section. So this is the metadata of the replica set, what we are starting a replica set. This is the pods that the replica set is supposed to start. कि replica set तू जो pod start करेगा ना, make sure they have this label. Make sure they have just one container right now, which is this. If you want to have multiple containers in the pod, you can put them here. The last section is selector. Selector का मतलब है कि how does the replica set know कि मेरे pods कौन से हैं? How does the replica set know कि amongst these 100 pods that are there, which one of these pods belong to me? Based on that, it will understand कि 5 हैं अभी या 3 हैं अभी कि 1 है अभी, and it will pull them out or start more or close some. तो this selector section represents कि यार ये labels match कर लेना. Whichever pod has app set to nginx, that belongs to you. What are we saying here? कि सारे pods में whichever pods have this label set, that pod belongs to you. If I manually start a 5th pod, a 6th pod which runs something random like MongoDB, but I attach these labels to it, तो इस replica set को लगेगा वो भी मेरा ही है. Replica set does not remember कि these are the 5 pods that I am starting. It just starts them. Then it checks कि यार app nginx वाले कितने हैं अभी, how many of these pods exist that have this label, and that's how it decides कि अच्छा 3 are currently running, replica set is 3, good. After 5 seconds, let's say one of them crashed, it checks only 2 are running, I will start a new one. So selector section is how does the replica set know कि कौन से pods मेरे हैं. Template section is replica set starting a bunch of pods. क्या जो भी pod start हो रहा है उस पे label attached है, उसकी container specification is this. Selector is कि कौन से container हैं that have app nginx. So the ones that it started definitely have this label. There might be more that you might add manually, and of course then the replica set will be confused कि अच्छा यार मैंने तो 5 start किए थे, 2 और manually start हो गए. It will kill 2 of them. Now it might kill these 2, it might kill these 2, but it will kill them. So you should make sure this is a very unique label that you have attached only to this specific set of pods जो आपको start करने हैं. अगर गलती से this label is present in a different pod, the replica set will think that pod also belongs to me. It will kill one of them because it needs to maintain this count of 3. Let's try it out. So थोड़ा try करते हैं, then we'll come back to this. The difficult part here is selector वाला section is a little hard to digest. Template I'm assuming is simple. कि you're starting a replica set. This is the name of the replica set. This is what I am starting. जो मैं start कर रहा हूँ उसमें मैंने कुछ labels दे दिए हैं. And this selector section is the most hard to digest for people. कि the pods that have started, they have this label. This is whenever the control loop is running, right? Whenever the replica set controller is running, it will check कि अच्छा we need to match these labels. So it will check how many pods have this label. उसके basis पे it will decide does it need to increase the pods or decrease the pods based on कितने अभी present हैं that are running and how many have how many replicas it needs to create. So that is this सेलेक्टर सेक्शन, ये थोड़ा हार्ड टू डाइजेस्ट होगा, धीरे धीरे इसको समझते हैं. लेट्स कॉपी द फुल replica set file. Let's create a replica set.yaml locally. Let's paste it. How many pods do I have right now? I have one. Let me delete it. I have deleted the pod. How many pods do I have now? I have 0. I have nothing running in my Kubernetes cluster. What does rs.yaml look like? What does replica set.yaml look like? The same thing we had in the slides. Let me apply it. Harkirat, can I run a command k create replica set dash replicas 3? Yes, you can do that, but you should not do that. You should always specify all the details in a manifest file. Let's apply it. K apply -f rs.yaml. And what does it say? It says replica set created. It doesn't say pods created. It says replica set created. If I do kubectl get rs or replica set, it shows me कि यार one replica set is running. Nginx replica set उसका नाम है. Where does the name come from? It comes from here. This replica set is running. The desired capacity is 3. The current capacity is 3. All 3 of them are ready. मतलब 3 pod actually चल रहे हैं. I did not start 3 pods. But if I do a k get pods, you will see Nginx replica set some random ID. One pod is already running. Nginx replica set, another pod is already running. Nginx replica set, another pod is already running. तो जो भी इस replica set का नाम होता है, that is suffixed with a bunch of random IDs, and that's how multiple pods are started. The most beautiful part of this is, number one, if I go to replica set.yaml and if I change 3 to 5, if I say, now I want 5 replicas, I have a lot of traffic. All I have to do is Kubernetes apply -f rs.yaml. What does it say? Replica set configured. क्या कुछ तो change हो गया वहाँ पे. Now if I do k get rs, it says yeah, desired is 5, current is 5. If I do a k get pods, I see 5 pods running. So I can create 20 pods, 100 pods, 200 pods. Of course, if the number becomes very big, let's do it. Let's, create, let's make this 1000. If I do that, of course, my cluster is going to, k get replica set. Now it says यार desired is 1000, current 5 ही हैं, ready भी 5 ही हैं, बाकी बन रहे हैं अब. Slowly, some of them will create, some of them will run out of memory, some of them will not be able to start. So if I do a k get pods, there are a bunch of pods, thousands of them, but most of them are stuck in pending or container creating. Some of them are running, but most of them are container creating, pending. They're stuck at a stage. So let me again make it, whatever, 2. And then k apply -f rs. Now the desired capacity is 2. Slowly it will drain them. एकदम से नहीं कर पाएगा because I started 1000. But you will see slowly the desired capacity and the current capacity it goes down to 2. Abhi the current capacity is 505. It started 505 pods. Slowly it will scale it down, and you will see the desired capacity and the current capacity will both become 2. So abhi I have a lot of pods running. But slowly you will see, a bunch of them will die, only 2 will be left. Do we understand replica sets? Do we understand the concept? Oh, one very important thing I forgot to show. Let me just delete the rs. So k get rs, k delete rs. K delete or so I force deleted all the pods because बहुत ज़्यादा हो गए थे. There we go. Back to clean slate. I have 0 pods running. K apply -f rs. I have new replica set applied और old replica set, but फिर से apply कर दिया मैंने, delete कर दिया था, फिर से apply कर दिया. K get pods. I have 2 pods running. They are starting. धीरे-धीरे start हो जाएंगे. Let's wait for them to start. So one command you can run is k get pods -w. That will start to watch the containers or the pods. अब जब ये start होंगे, then you will see them over here. So I'm watching this. It's taking some time. So whenever this happens, you should do a k describe pod, the pod, and you will see क्या हो रहा है. It is pulling the Nginx image from hub.docker.com. तो image यहाँ पे आएगी, उसके बाद ही start होगी. तो still watching it. It is starting. Most probably because we started 1,000 containers. So, whatever, it's being slow right now. We'll wait for it to happen. But one more experiment I wanted to run, जो मैं कर नहीं पा रहा हूँ, is कि अगर मैं इनमें से एक को delete करूँ, right? If I run k delete pod this thing, वो अभी delete नहीं होगा वो क्योंकि वो अटक गया है. But long story short, as soon as I deleted this one is terminating, but एक नया start कर दिया. The replica set started a new one. It said here this one is terminating now. ये तो मरने वाला है. So let me start a new one. It will always maintain 2 pods. It will always make sure कि 2 pods either they are running or they are about to start their starting. It can just do a best effort, right? It's trying कि 2 start हो जाएं. Right now my cluster is messed up because I started 1,000 containers in there or 1,000 pods in there, which is why it's not able to start them. But it is trying its best to make sure कि 2 ही रहें. Because the rs.yaml file says the number of replicas needs to be 2. So do we understand replica sets? Let's do a poll. Do we understand them? Can we read the manifest? Can we understand the manifest? Do we understand how as we change this number, it upscales. If we change this number, it downscales, and so forth. Already beautiful. Be foolish, 85%, 86%. So good, not bad. I'll do deployments and then then we can do a Q&A because deployments is also hard. Uske baad I can do Q&A. I'll quickly recap what we learned, which was replica sets. Then we'll do deployments. Then I'll do Q&A and जिसको नहीं समझ आया उसको समझ आ जाएगा. All right. To recap, हमने 2 Kubernetes resources पढ़ ली हैं. We have learned about right now. We have learned about pods. We have learned about replica sets. क्या क्या पढ़ना है हमें भी? Deployments, services, certificates, certificate manager, PVCs or PVs, secrets, config maps. Is there any other custom resources? Chalo. We have only learned these 2 right now. We are still to learn so many of these. Kubernetes has a lot of resources they have defined for a bunch of things. One more important one is ingress. We're going to learn all of these slowly. Today, our goal is to make sure we can understand deployment as well. If we understand these 3, that's probably 50% of your time will go there. In fact, if you look at one of our ops repositories, right? If you look at staging ops, and you open any application, let's say prod/CMS, you will see there is a deployment.yaml. There is an application.yaml, which you don't really need. Certificate.yaml that we will understand when we understand, a certificate manager wala part. There is a sealed secret.yaml, which again I forgot, which is, basically this thing right here, some variation. Then there is deployment.yaml. So if you notice, 20% of our final production code is going to be a deployment. 20% is going to be a certificate, 20% is going to be this. But any application that you look at, let's say job board, it has a deployment, certificate, application, sealed secret and service. These are the bigger resources that you use. So अब हम deployment पढ़ रहे हैं. Replica set we have learned. Generally, you don't create replica sets. That is why you don't see it in a production repository, right? Open any random project from here. In the staging environment, open daily code, and you will see there is no replica set.yaml here. There is a deployment.yaml. There is no pod.yaml either. कोई pod की manifest भी यहाँ नहीं है. कोई replica set की भी manifest नहीं है. Deployment is the very first resource that you will actually use in production. That is what we're learning next. Now let's jump back a few slides to deployment. Deployments will feel very close to a replica set. ऐसा लगेगा कोई फर्क ही नहीं है. You will feel like a deployment and a replica set is exactly the same thing. But they aren't, and we'll understand why. A deployment in Kubernetes is a higher level abstraction that manages a set of pods and provides declarative updates to them. So the first part we have already seen in replica sets. It manages a bunch of pods. If there are 20 pods running, but the replica set count is 40, it will increase the number of pods to 40. If I decrease the replica set or the replicas count to 2, it will decrease the number of pods to 2. So it already does the concept of managing pods. What replica sets don't do, and this guy does, is providing declarative upgrades to them. We'll understand what that means. It offers features like scaling, rolling updates, rollback capabilities, making it easier to manage the life cycle of application. Lot of things written over here. Let's start off with the life cycle of applications. एक application जब deploy होती है, an application when it deploys, you have to keep redeploying it again and again. Like every day, developers are committing code to it, right? There it's being deployed. That's the life cycle of an application. Deployments provides you scaling, which means just scaling the application up, scaling the application down. That replica set also provides, nothing new there. Rolling updates. What is the rolling update? If you deploy a new version, then slowly rolling out the new version. You have 10 pods running of the old version. अब कोई नया commit आया, it reaches the Kubernetes cluster via CI/CD. It will not stop the 10 pods and start 10 new pods. It will do a rolling update, which means 10 pods हैं. पहले it will start one pod of the new type, then it will stop one pod of the old type, then it will start a new pod of the second type, stop the new pod of the old type, so on and so forth. Rolling update. कि धीरे धीरे the new code reaches the users. You don't immediately stop all the machines and then restart all them, or stop all the pods, restart all the pods. You do a rolling update, which means धीरे धीरे you drain the old pods and start the new pods. Rollback capabilities. अगर गलती से there is some bug, then you can just roll back the deployment to one version before. That means the old version will start running, making it easier to manage the life cycle of the application, which means as code gets committed, धीरे धीरे it will start to reach production. It will not immediately bombard. If there is a bug, then you can roll back, so on and so forth. This is the master node in Kubernetes, and this diagram is a little wrong, so let's not go here. There's a better diagram in the replica set slide that we will go through. This diagram ko ignore karo because this isn't technically correct. We understand what a pod is. A pod is the smallest Kubernetes object. It represents a single instance of a process running in your cluster, typically running one or more containers. A deployment is a high-level abstraction, high-level controller that manages a set of identical pods. Now, this statement is slightly incorrect. A deployment doesn't manage a bunch of pods. It manages a bunch of replica sets. I repeat. ये पार्ट ही सबसे important है और अगर चमक गया तो your life will be very simple. When you create a deployment, it creates a replica set which creates a bunch of pods. Pod number 1, pod number 2, and pod number 3. That is the life cycle of a deployment. अगर आपने एक deployment पहली बार apply करी, you do a kubectl apply -f deployment.yaml. What this guy is supposed to do is just start a replica set. When you apply deployment.yaml, you will mention replicas here also. कि मुझे 3 replicas start करने हैं. So the deployment will just create a replica set with replica set to 3. A replica set is what will create the pods. A deployment doesn't manage pods. A deployment manages replica sets. A deployment manages replica sets. A replica set manages pods. तो अगर आपने deployment को पहली बार apply किया, let's say you had replicas set to 3 over here and image set to 100x devs / I don't know, probo backend version 1. So if this is the configuration that you apply, there will be more things in the configuration file, the manifest file. But let's say replicas were set to 3, image was set to this. If you look at staging ops key deployment.yaml, amongst many things, there is an image that we are starting, 100x dev / daily code staging with a tag. There is the other thing, replicas. So there is replicas set to 2. ये दो चीजें तो हैं. There are a bunch of other things in deployment.yaml, but ये दो चीजें तो हैं. How many replicas you have to start? Which image you have to start? So when I do k apply -f deployment.yaml with this replicas and this image, एक replica set बन जाता है, which is doing this, starting 3 pods. Now if this pod crashes गलती से, the replica set will make sure it brings it back up. If 2 pods crash गलती से, the replica set will make sure the pods come back up. Question is, what happens when a update comes? What happens if now we want to make a new release? if we want to change the image that is being deployed. अब हमने एक नई डॉकर इमेज बना दी with our fresh code which has 10 different features. When I reapply the deployment.yaml, when I change the image to be probo backend :v2, this is the Docker image tag. Every Docker image, let's say Mongo, has various versions or what are called tags. So, this is one version, this is one version, this is one version, so on and so forth. As you deploy your application, make it better and better, GitHub say, your code will eventually reach Docker Hub. Your image will reach Docker Hub. उसका tag update होता रहता है. Version 1, version 2, version 3, version 4, so on and so forth. तो पहले तो deployment.yaml में probo backend version v1 चल रहा था. तो Docker Hub, hub.docker.com / whatever 100xdevs / probo-backend. This image is version 1 was running. Now I want version 2 to run. And now I want a different tag to run. So what will happen? Will the deployment update the replica set? Will it tell कि यार अब image change कर दो from this to that? No. Deployment creates a new replica set. पुराना वाला भी रहता है. It creates a new replica set. It takes this image and attaches it over here. So now I have two replica sets. The first one running 100xdevs / v1 and the second replica set running 100xdevs / probo backend :v2. Iski replica count is 3, which is what is defined over here. Iski replica count initially is 0. The deployment is doing a rolling update. Rolling update मतलब कि यार पहले तो replica set का जो नया बना है, the count would be 0. Then slowly this count will be updated to 1. And a new pod will start. A new pod will start, which is running probo backend :v2, a new Docker image, the updated version which has 10 different features. These 3 are also running. This 4th will also start, which means some 25% of your traffic will now see the new version of the application. 75% of the traffic will see old version of the application. That's what's called a rolling update. Now once this becomes healthy, deployment will be like, yeah, teri replica count now is 2. So replica set will stop this first pod. Then it will increase the replica count here to 2. A second pod will start. Once this becomes healthy is when it will tell the old replica set ki yaar, now your replica count is 1. And similarly, then it will tell the new replica set ki yaar, now all the traffic is going to come to you very soon. Please start the third and the final pod as well. Third pod will start. When it becomes healthy, it will tell the old replica set, bhai tera ho gaya. Your replica count now is 0. Now 100% of your traffic is seeing the new code. This is what is called a rolling update. Deployments help you create a rolling update, help you make sure your application is healthy. If you look at it, rolling updates are so cool. Here, if you give it a faulty image by mistake, galti se your code has some bug, what will the deployment do? It will start a new replica set, which will start a new pod, but this pod will never become healthy. This pod will always remain in error, and hence these 3 replica counts will be maintained. अगर जब तक ये green नहीं हो जाती, जब तक this pod doesn't actually start, the old replica count will not go down. It's a rolling update. Slowly the old pods are being drained, new pods are starting. So that is why a deployment is different from a replica set. A replica set manages the pods. Deployment manages replica sets and does a rolling update like this. Slowly downscale the old replica set, upscale the new replica set. Now let's read through. How do you create a deployment? We understand how to create a replica set that we saw a while back. Let's understand how to create a deployment. It's very similar to a replica set. बिल्कुल फर्क नहीं है. API version app/v1. What are we trying to create? We are trying to create a deployment. A name for the deployment. In our case, it's Nginx deployment. Specification. कितने replica start करने हैं? 3. Selector. Same as replica sets. कि यार हाँ, the replica set will match labels app::Nginx. And template. What is the labels that we are adding? app::Nginx. What is the specification of the container to start this? So it's exactly the same as a replica set specification. Only thing that is changed is this, replacing replica set with deployment. But the benefit is, as we update this, we will see how deployments are orchestrating replica sets and how replica sets are orchestrating pods. So let's try it out. Let's try to copy the manifest. Let's delete the replica set that we have already. So kubectl delete replica set, nginx replica set. Copy the deployment.yaml, paste it, and now if you look at deployment.yaml, same as replica set.yaml, only this thing has changed. And of course, the name is not nginx replica set, the name is nginx deployment. What deployments do I have right now? Nothing. What replica sets do I have right now? Nothing. What pods do I have right now? Nothing. I have no resources in my Kubernetes cluster right now. Let me start just one resource, deployment. Kubernetes apply or kubectl apply -f deployment.yaml. What does it say? Deployment created. Did it say replica set created? No. Did it say pods created? No. But have they been created? Yes. If I do a kget deployment, you will see it says one deployment has been created, which is ready 3 on 3, and all 3 of them are available. If I do get replica set, notice the first replica set has been created. The first replica set has been created. The first replica set has this as the name. So nginx deployment a random hash. The deployment created the replica set. Hence the name is nginx deployment dash a random hash. And what is the desired capacity, current capacity, how many of the pods are ready, so on and so forth. And lastly, if I do a kget pods, I have 3 pods running. What is the beauty? The beauty is if I delete one of the pods, the pod will delete, but it will immediately restart a new pod. This pod was deleted, but a fresh pod got created 2 seconds ago. Why? Because a replica set mein desired count is 3. The replica set says desired count is 3, and so if I delete one of them, it will restart that specific pod. It'll understand कि अच्छा 2 रह गए हैं, start a third one. Kget deployment, I have 1 deployment. Kget replica set, I have 1 replica set. Kget pod, I have 3 pods. How do I do an upgrade now? How will I change the image to something new? Because our application lifecycle will slowly update images, have more things there, so on and so forth. So how do I update the image? vdeployment.yaml. Replace image from nginx latest to, MongoDB latest. Let's say we now want to start the MongoDB image, not the nginx image, for whatever reason, but under the same deployment, which means it's sort of the same application. It makes no sense. अगर हम nginx से mongo जाना doesn't make any sense. nginx version 1 से version 2 पे जाना makes sense. Eventually, when we deploy our own backend, we'll keep the image name the same. We will change the version 1, version 2, version 3. Just for testing purposes, I am changing the final image that is running from nginx to MongoDB. Just to see कि क्या rolling update हो रहा है धीरे धीरे. तो let me close. Let me apply the manifest again. Reapply deployment.manifest. And while this is happening, in the other tab, let me do a kget pods -w. Let me watch for the pods. So abhi 3 pods are running, all of them running the nginx image. Now I am updating my deployment. I am telling deployment here, please start the MongoDB image. So when I do this, notice 3 already हैं, 3 और बन रहे हैं. Actually, this is a better thing. 3 already हैं, 1 और बन रहा है. Rolling update is happening. Existing 3 are already there. 1 new has been started. If I do a kget replica sets, you will see old replica set has 3. New replica set had 1. पहले ये 1 upgrade होगा, healthy होगा. फिर this will downscale to 2. Then this will become 2. This will downscale to 1. Then this will become 3. Then this will downscale to 0. Now you will see 3 are here. 2 of them are ready. तो यहाँ पे अभी एक पिछले वाला चल रहा है, एक पिछले वाला चल रहा है, 2 आगे वाले चल रहे हैं. After some time, you will see old replica set has been downscaled to 0. New replica set has been upscaled to 3. By the end of it, I still only have 3 pods. But now they're running the MongoDB image. If I do a kubectl logs of this pod, you will see this is MongoDB logs. This isn't Nginx logs. So now all 3 of my pods are running MongoDB. Let me change it again. Let me change it this time to some random image that doesn't exist. This image doesn't exist on hub.docker.com. Let me apply the deployment which has a random image name. Now, when I do a kget replica set, notice old replica set still has 3. New replica set is starting out with 1. But unfortunately, the new one has an error. Error image pull. It is not able to pull the image. And since it is not able to pull the image from Docker Hub, the 3 pods, the old pods, will be maintained. Isn't this beautiful? If you were creating a virtual machine where you were pulling your code and rerunning it, if your application had a bug, it would just crash. Here, it is crashing. Naya code is crashing, but old code is still alive until this comes back up. Slowly, Kubernetes will keep retrying to pull the image from Docker Hub. Maybe eventually Docker Hub has this image. Then it will be able to pull it and run it, and then slowly it will upscale. This will downscale. But abhi ke liye, the rolling update got stuck in the middle because this is an erroneous image. This image does not exist. So do we understand why deployments are different from replica sets? Why? Deployments are different from replica sets because deployments orchestrate replica sets. They decide that naya replica set needs to be started. Slowly its replica count needs to be increased. Slowly its replica count needs to be decreased, so on and so forth. And slowly, helps you do a rolling update. It lets you scale up, scale down. It lets you roll back in case there's an error. You can go from this replica set to this replica set, so on and so forth. That is why deployment is used. Rarely will you ever create a pod yourself. Will you ever create a replica set yourself? You only create deployments. That is what I showed you in the final code that we have that deploys a bunch of applications, in our Kubernetes cluster. We only have deployments.yaml. You will not see a replica set.yaml here. You will not see a pod.yaml here. There are a bunch of other files that we learn about eventually. But deployment.yaml is the only file that we sort of worry about. Do we understand this? Let's do a poll. Do we understand the concept of deployments? Then we'll do an assignment. We have time. Then we'll do Q&A. I'll do an assignment first. %. Good, not great, but pretty decent. I'll do Q&A in a while. I think 10 more minutes. Let's do an assignment. The assignment is create a manifest.yaml file which starts a Postgres DB, one replica. I want to start a Node.js application, but let's say Nginx application, 3 replicas, and Redis again 1 replica, and to get fancy, let's say Mongo 1 replica. But let's not do this. Let's do this. अब assignment कर रही हैं तो ढंग से करते हैं. A custom Node.js application that connects to Postgres. चलो इतना कर लेते हैं बस. Let's not go too fancy. This much. Can we सबसे पहले create a custom Node.js application, deploy it to Docker Hub, push the image to Docker Hub. So we'll have to create the Docker file for it, deploy to Docker Hub. Then in our Kubernetes cluster, start Postgres, start this, and try to connect the application to the DB. It will not happen. We have not learned about the next concept in this series, which is going to be how to expose the application. So we need to understand this for this to actually work. But just to, get our hands dirty, start a custom application in our Kubernetes cluster, not just Nginx, not just Postgres, not just MongoDB, our own application. Can we try to do this? This is the assignment. Take 5 minutes and try to do it. And then I will do it as well. Tab tak I'll look at Q&A. But this is the assignment. Create your own Node.js application which connects to Postgres. Use PG library, use Prisma, use Drizzle, doesn't matter. It should just be able to put data in a Postgres database, and then start Postgres and the Node.js application in a cluster. It will not work. They will not be able to talk to each other. But you have your own custom application running. How to roll back? There is so I forgot the exact command. But deployment rollback, there's a single command that you can run that will roll back to the previous version of the application or the deployment, which is very good. It gets more complicated, but kubectl rollout undo deployment to version this. So let's try this. Let's reload back to our deployment / what was the deployment called? It was called Nginx deployment. So this would roll back the Nginx deployment to the very first deployment that we made, which was for Nginx image. So now if I do a kget pods and k logs -f this, you will see Nginx logs, because what was the very first version, very first revision? It was Nginx. Second was MongoDB. Third was a custom image that did not exist. So when we rolled back to version 1, we rolled back all of these. As you can see, they started 10 seconds ago, 7 seconds ago, 4 seconds ago, because I rolled back to our very first version of the application. How do you scale it? So kubectl scale deployment, whatever is the name of our deployment, Nginx -deployment -- replicas 1. That will scale down the deployment to 1 replica. Generally, though, you should do all of this in the manifest.yaml file. So over here, sorry, not here, but in deployment.yaml is where you should change the image to the right image, or change the replicas to the right replicas. It's just under extreme conditions कि आपकी application फट रही है, you can run this command to quickly roll back or quickly scale or scale down. Let me look at Q&A until for a few minutes, and then hopefully you guys are shit charging. Cool. He asked Kira to change his lap or charge his lap. Oh god. Is this called blue green? Not exactly, but very close. Blue green has the concept of, if I'm not wrong, if my memory comes back to me, it has the concept of spike monitoring, and the same thing happens. There's a blue deployment, there's a green deployment. कि हाँ, नई deployment start हो रही है, पुरानी deployment बंद हो रही है. But there is, you monitor the spikes of error messages, and based on that you decide कितना upscale downscale करना है. This, I don't think this exactly is a blue-green deployment, but we can read about it. I read about it like a few years ago. A few people are saying that this might just exactly be blue. Let's just Google it. Blue-green deployments. In which you create 2 separate identical environments, one for the current application, one for the... This is more of a rolling update, and probably not a blue-green deployment, but we can read through this as well. Or you can just, the main thing to it is deployment in Kubernetes cluster blue-green deployment. And the answer is sort of yes. Only Kubernetes blue-green deployment is everything. Yeah, seems like it's not as easy as just updating the deployment, and you have to do more things. I can spend time here. Let me just look at more Q&A, and we can read through it. In deployment spec, replicas 2 means the replica set will start 2 pods. That is correct. It means the replica set will start 2 pods. Are control loops or controller memory intensive? Because whenever we're running an infinite loop, our CPU is completely eaten. Not necessarily true. Just because it's an infinite loop doesn't mean there isn't context switching between, one controller to another. I haven't gone through controller code. I'm assuming there is no cool off between loops over there. It is in actuality an infinitely running loop, but or it might be there is a cool off. Every 5 seconds it gets called, every 2 seconds it gets called. But even if there isn't, there will definitely be context switching between all the controllers. So it's not like one controller will eat up all of your CPU. Anyways, those controllers are running on a master node where your pods aren't running, so they won't interfere with your workloads. If you run 3 pods in a node with the same container using a replica set, okay, how does the port mapping happen? Request should be forwarded to one pod, right? So not exactly. If you run 3 pods with the same container using a replica set, how does the port mapping happen? It should not be forwarded to one pod, right? It should be load balanced amongst all 3 pods. Do you get that? If you start 3 pods that are running the same container, whenever external traffic comes, you want it to be load balanced amongst the 3. You don't want it to reach one pod. How does port mapping happen is a different question. Okay? That is where we will learn tomorrow about services. Okay? How do services let you expose applications? But do you understand this case? You don't want one pod to hit. Even if on the same node 3 pods are running, you want the traffic to be load balanced. Kubernetes architecture is good. In fact, if you ever try to create your own controller, is when you will understand how easy this architecture is. Like you can create this, something like this. You can create some parts of this, in whatever, Node.js or Python as well. Some parts. By some parts, I mean, this deployment controller, replica set controller, because eventually when you create your own controllers, you sort of write very similar code to, have a loop that is checking something. I'm forgetting what exactly I was creating recently, where I had to read about it. But this whole architecture of something called as Kubernetes operators, in which you have to create your own controllers. And a controller is nothing; it's just a Golang file, or it could just be a Node.js file. That has an infinite loop that's checking something again and again. So what would the deployment controller do? It would just read case, has there been an update since the last time? Oh, there has been an update. It will create a new replica set, and that is it. It will update the replica set count to 1, and then 2, and then 3, and downscale the other one. So the infinite loop is just checking this again and again. What would a replica set controller do? It would check kitne pods abhi present hai, what is the current replica count, and upscale and downscale accordingly, so on and so forth. Is Kubernetes also recommended for on-prem deployments? You can do it. Is it recommended is a good question, and the answer is yes. I mean, there's no one stopping you from doing it. But generally, the place I've seen it on cloud. So I've never seen someone deploy their own Kubernetes cluster on bare metal, for example. I've only seen people create clusters on cloud. So deployment, we check new feature risk like routing 20. Yeah, so we don't do that. We don't check. We are slowly scaling up the deployment. We're not checking, how many requests are healthy. As long as the process exit code is 0, it's a healthy process, whatever your health check might be. For most processes, it's, whether or not the process is running. Agar ek Node.js process start kari hai, as long as the Docker container doesn't exit, the deployment will happen. So we're not actually doing traffic monitoring. Are users seeing a 404 status code now and upscaling based on that? We are only upscaling based on the process health. So the process could have very ugly code, very bad code, and your users might see a lot of problems. But as long as the process Kubernetes thinks is healthy, it will start to upscale your application. And rollbacks can be same. It will only roll back if it feels the application, the process isn't healthy. But if you have buggy code in there, if it crashes the application, great. If it doesn't crash the application, but it's buggy code, Kubernetes will start your new deployment. A bunch of questions unrelated. In the a bunch of projects, infinite. Someone said blue-green has load balancing between current and updated. So that's true for this guy as well, right? As new pods are starting, traffic will start to get load balanced amongst the current and the latest. This isn't exactly blue-green, right? Exactly. So what is the difference is what I was asking. But that my spidey sense tingle with the same thing. I think blue-green is a little more complicated than, a rolling deployment. What we have is a rolling deployment. This isn't blue-green deployments, but we can read through what that is. If the pod is about to get crashed or gets crashed, because it brings up a new one, that is correct. What happens to the application data which it was processing? Is it lost? For example, the customer order, where we lose the order data. So it's the same thing that would happen if the application crashed on a virtual machine. If the user was hitting your virtual machine, you were doing a database update and the process crashed. Either the database update will persist or it may not persist, but your user will not see a response code. Your user will see a 400, or whatever, or 500. The application crashed, backend crashed. Same thing will happen here. So nothing different will happen compared to, if a virtual machine stops running, if the process crashes on a virtual machine. So a pod isn't anything new or anything complicated. That specific request will be dropped. The user can retry it. The user will see a 404 status code and alert on the front end that will say unable to connect to the backend or something like that. Stateless class when? What do you mean stateless class? What do you mean stateless class? In Kubernetes deployments, we can roll back to older versions, which means images are stored on the machine. Won't this create significant residue after applications are aged? So that's not necessarily true. If you're rollbacking, it might only know the image name. It might have to re-pull it from Docker Hub. Most of the times, these images are cached, and at some point they expire and leave the machine as well, or the cluster as well. But doesn't necessarily, if you roll back, doesn't necessarily mean that image is there. Just the image name might be there and might have to re-pull the image from Docker Hub. Yeah, answered that. So can we apply for cloud engineer? Okay, yeah, I mean, yeah, so a few of this, a bit about this depends on your luck. For example, I know two people who got into a company. I mean, they were already in a DevOps company, so maybe they had an edge, but they got a very good offer, like 100K plus. And they were asked the simplest things, which we'll probably learn in the next class. They were asked to debug a bunch of these, manifest files, and I can tell you what was the wrong thing there. They something like this. Selector labels were Nginx name or Nginx app. And the match labels were Nginx app and the template had app Nginx, something like this. So ऐसी एक file थी, उनको खोलना था, they had to debug it and reapply it. It was as simple as that. Like most of you can solve it. After you've done probably the next class. Interviews में, especially for whatever the first entry level, if you're able to do this, you're good. At least for the companies that I've seen until now. So when you create rs.yaml, there's no need for pod.yaml file. That is correct. Like how Docker Compose exactly. That is true. Like for Docker Compose, you need a Docker file. Sort of you do, but yeah, you're on the right lines. If you create a deployment, you don't need to create a rs.yaml. You don't need to create a pod.yaml. All the orchestration is happening by the deployment controller. The same way, how RS knows which pod is config should be. Oh wait, like how Docker Compose file depended on Docker file, or maybe it have config in Docker Compose file. That is correct. The same way, how rs.yaml knows what is the pod config should be. Yeah, you haven't looked at rs.yaml very well then. If you look at replica set.yaml, which is, creating a replica set, this slide, notice when we describe the replica set, charging, when we, daisy, I probably need to share my screen again. When we start the replica set, we clearly tell the specification of what we want to start. We want to start, this specific section is clearly telling, right, कि एक नया image start, I need to start a pod which has these containers. In this case, just one container जिसका नाम Nginx है. Image जो start हो रही है ये है. Port mappings जो है ये है. So this is where I'm clearly specifying कि pod कैसा दिखना चाहिए. I've not created a separate pod.yaml and pointed this to pod.yaml. In the same file at the bottom, I have described what should the pod specification be. How do I restart a cluster? That is a beautiful question. I don't know the answer for. There are maintenances. Like you can, for example, I can go to my resources here in my production cluster and I can, not resize, but I can recycle nodes. So if I select one of these nodes, preferably the, I'm hoping this is the worker node, but what I've done is I've recycled one of the nodes, which means this will, come down, a new node will come up, and then, the pods will be redistributed across this node, and the new node. So if you feel like a pod is giving you, or a node is giving you problems, you can recycle it. How do you restart the full Kubernetes cluster? Never done it. But, one idea to throw is, remove all the nodes and then, create a new node pool. Or create a new node pool first and then, decrease the old node pool, so on and so forth. So Kubernetes maintenance, which is probably a big topic, is something I haven't done ever. I've just been lucky that the clusters that I have created have been up. how can we define the, we should discuss that though, okay, how, because I think it's a very important topic to know, okay, how does node management happen, not just increasing and decreasing the number of nodes, but node maintenance, okay, if you know, what if let's say your cluster is down one day and all the nodes are not ready, by not ready I mean, you know, the status is, if I do a k get nodes right now, you'll see all of them are ready, but if they become not ready, then how do you debug it? Is, you know, an important thing to learn. Explain selectors once more. Let's see. Selectors. Yeah, sorry. This thing right here, right? ये एक अलग section है. Let's look at all the sections. ये section सबको समझ आ रहा है. The metadata about the replica set, the name of the replica set, what we are starting is the replica set, the version in which it is present, so on and so forth. Specification. Replicas हमें 3 start करने हैं. We want to start 3 replicas. We can increase it to 5, decrease it to 2. Selector को छोड़ देते हैं अभी के लिए. These 3 lines are sort of, you know, independent, अलग से चलेंगी. Template समझ आ रहा है कि what are we going to start? हम जो start करने वाले हैं वो क्या है? We say यार जो भी start होगा ना उस पे ये label डाल देना. Put metadata labels app nginx over there and start these pods. एक pod start करना है जिसमें एक कंटेनर होगा. One container is there. The name of the container is nginx. This is the image that needs to start, and this is a port mapping or the port that is open on that container. So this is the pod specification. This is the replica set specification. This is the number of replicas. What is this? This is कि यार जब वो कंट्रोल लूप चल रहा होगा रेप्लिका सेट का, हाउ विल रेप्लिका सेट नो कि यार जो पॉड्स रन हो रहे हैं, which one of them belongs to me? Let's do an example. Let's do, you know, we have a pod.yaml, right? We have a manifest.yaml. एक quick example कर लेते हैं, उससे समझ आ जाएगा. And यहाँ पे along with the metadata, let me add labels app:nginx. ठीक है, ये एक मैनुअल पॉड मैं स्टार्ट कर रहा हूं. आई एम स्टार्टिंग अ मैनुअल पॉड. बाय मैनुअल पॉड आई मीन देयर इज अ pod.yaml or manifest.yaml where I've defined a pod specification. I've defined a pod resource. When I apply this, if I do a k get pods, I have this one pod running and I have a deployment pod running. Let me delete the deployment. So now I have a single pod running. Let me describe the pod. K describe pod this thing. Notice this pod has labels app equal to nginx. तो मैंने manually एक pod start किया. I started a pod manually which has app set to nginx. Now let me open replica set.yaml and इसमें क्या है? इसमें लिखा है यार selector is match labels app set to nginx, which means एक pod जो हमारा चल रहा है will now belong to this replica set, even though this replica set hasn't started it. ये replica set उस pod को चला नहीं रहा है, but because we have written buggy code, हमने थोड़ा सा गलत कोड लिख दिया कि these labels should be unique, should be same here and here, but should not be present in a different pod, वरना replica set confuse हो जाएगा. अब replica set 2 चलाना चाहेगा, it will want to start 2 replicas with app set to nginx, but unfortunately there is already a pod running. So if I apply this replica set, k get replica set says कि यार desired 2 हैं, current 2 हैं, ready 1 है, बहुत जल्दी ready दूसरा भी हो जाएगा. k get pods. Notice हमारा old वाला चल रहा है और एक ही नया चला. Our old one is running and only one started. Why? I तो had replicas set to 2. Why did only one start with this weird name? Why did the second one not start? Because the one that I manually started, also has app set to nginx in the labels. When I described this, k describe pod nginx, इसमें label था ना एक, labels app equal to nginx. So what does selector mean? Selector is replica set wants to know कि यार which one of these 1000 pods or 100 pods belongs to me. Replica set doesn't remember कि यार ये 3 मैं start कर रहा हूं तो ये 3 मेरे हैं. No, replica set simply starts 3 pods and attaches these labels to them. Now, if I start another pod and attach the same label, then replica set is confused. It's like, यार तीन तो मैंने चलाए थे, चौथा कहीं से तो आ गया, so it will stop one of those four and it will downscale to 3. So in this case, that is why there weren't 3 new pods that were started. There is only 1 new pod that is started, even though replica set has replica set to 2, because this one also belongs to the same family now. This one also matches this selector label, and hence replica set is like, okay, one is running with this label, one new I will start with this label. If you remember, we cancelled a class last week. No, we did serverless. We did that was last week, I think. Last week was serverless Kubernetes 1, and then I think Solana contracts. We defined only one container to run our file. What if we get 2 containers? And same thing, right? You can define multiple containers here. Pods 3 ही start होंगे. If I add more containers here, name, let's say, I don't know, Mongo, image, Mongo colon latest, ports, container port 27017. Now I'll start 2 containers, but still same number of pods. So, k delete replica set, nginx replica set, k apply replica set. I have some bug in the forgot the colon over here. If I apply this, how many pods are starting? Still only 2 pods are there, but हर pod के अंदर 2 containers start हो रहे हैं. So every pod is now starting 2 containers. If I do a k logs -f of this thing, it says defaulted to container nginx. ये कह रहा है कि nginx के logs तो ये रहे भाई, but container 2 चल रहे हैं. If you want, you can look at the Mongo logs as well. So you can do k follow logs -f this thing -c Mongo. तो मुझे Mongo के logs दिख जाएंगे. And if I want, I can also see the nginx logs. So now I have 2 containers running in the same, whatever pod. One more request. Can you please do one pod with Nikhil? Yes, we did discuss this. He's busy, but I'll try. I've done a one-on-one with him. I can tell you all the alpha. The alpha from his side is it's very hard to find good engineers. We discussed the same thing. But again, their requirement is really high. He's a little too smart. He's done a lot of research in a lot of things. So, whatever, basically DevOps related. And hence, this was a pretty ideal role for him. What if I use a custom Docker Compose file instead of pulling images from Docker Hub? So you can't use Kubernetes clusters for packaging Docker images. That's not its job. A Kubernetes cluster is supposed to run images, not package them. So you can't throw a Docker Compose and a Docker file at it and hope for it to run it. So yeah. So serverless we did last week, Saturday. Maybe it's not posted, but I hope it is. All right, what else? The random number pod is done, it is automatically done by Kubernetes. The random ID, not number, but yes, it's automatically done by Kubernetes. Full stack project, all tech that we have covered until now, we should do it. You should go through the Web3 SaaS video that I have. That does cover almost everything we have done until now. But we'll do projects. Let me finish Kubernetes. Then let's do an end-to-end project. Kubernetes and Helm and GitOps. After we've done these 3 things, it'll probably take max 3 weeks. I'm happy to do that. A Blue deployment, both Blue and Blue are active at the same time. 100% of users only see one version, and other one is tested in the background. And once the tested traffic is switched, so there's more meticulous testing that is happening in a Blue Green deployment. Compared to here where it's random load balancing between the new deployment and the old deployment. How does pods created by RS deployment get distributed amongst nodes? So here you should go back to the Kubernetes architecture. We have discussed this, but every Kubernetes master node has this thing called the scheduler. So where is it? Yeah, there we go. If you remember, we went through the master node, where there was this process called the cube scheduler. So the cube scheduler is sort of responsible for figuring out what is the best node, and then it stores that mapping. Okay, this pod should start on this node over here in the not distributed, in the key value pair or whatever, this database. And then the worker node has something called the kubelet that is running, that talks to the API server, which is again it's a control loop. It's talking to the API server, checking kya meko kuch aur run karna hai kya. And if the API server says ki, you are supposed to run this pod, then the kubelet will start to run. This is not very hard to replicate, other than the real container runtime and actually starting the process. Writing your own Kubernetes, for example, in Python or JavaScript or Go for that matter, is not too hard if you understand these components. Like replace etcd with a Postgres database. Replace the controller manager, just start a deployment controller, replica set controller, a pod controller. Scheduler can just be a Node.js process that's randomly putting pods on a node. That's it. API server is simple Express server. And here you don't worry about kube proxy, don't worry about services, don't worry about external traffic. Just assume pod management. It's not too hard to create that yourself. Kubelet just needs to talk to the API server and figure out kaun sa usko start karna hai. Just do a Docker run that specific image name. Something like that. Cool. How does the pod created in RSpayment get? Okay, I answered that. To make local recording so we can solve everyone's question before you give the answer. Yes. So today I am doing local recording, so it'll teach you. Can one replica set have templates of 3 different? Ye kya incomplete question hai. Can one replica set have templates of 3 different? And that's where the question ends. So I don't understand the question. Did you learn DevOps on the job? Yes, I did. So all the Kubernetes, I do explore from time to time, but all the real DevOps, so 100% I learned on the job. Back in the day, and Kubernetes I learned in a few years, not a few years, like 1.5 years ago or so, where we were deploying everything to Kubernetes. Prasoon Pratham also, name rings a bell. I forgot who he is. All right, that's done. Let's go to the bottom. Any other Q&A? Another offer I got to work at WordPress. I'm stuck. Should I take the jobs? No, you should take it. I'm assuming you mean WordPress and not as a WordPress developer. There's a big difference between them. If it is WordPress, you should definitely go. If it is a WordPress developer, that's also not the worst thing in the world. 30% of the traffic all around the world is WordPress. I'm still exploring Docker and Docker Compose and then Docker Swarm, because Kubernetes may be an overkill from a small project. Yeah, that is right. But again, Docker Swarm is dead. Don't use that. Just use ECS, or don't use anything. Just deploy in a VM. Deploy a Docker container on a VM. I would not. There's no need for you to do Docker Swarm. If you want to do it for for random testing, then do it. I understand one stack and contribute to Gumroad. Not really. So why? No, you need to learn Ruby on Rails. You can try and, so basically don't do it until you know Ruby on Rails. There's no point. Because I'm assuming you're contributing because you want a job. So for that, that's a bare minimum thing that you would have. I'm not saying don't do it. I'm saying first learn Ruby on Rails well. Then contribute to a different Ruby on Rails code base. Write your own projects. Write projects similar to them. उनकी कोई module library पकड़ो. उस library को use करके कुछ बनाओ. Then dive into their code base. Cool. I'm confused with nodes. Are they VMs? So they could be bare metal machines. It could be my Mac machine. It could be a virtual machine. So yeah, a node is nothing but a machine. Could be a virtual machine that's running Kubernetes master node ka code, which is basically these 4 processes and a bunch of more. Or if it's a worker node, it's running these 3 processes. So it's just a normal machine. Now could be a AWS virtual machine. Could be a normal Mac machine. Could be a bare metal machine where you're running Kubernetes. Master node code or worker node code. Answer that. While using kind, we are running each node as a Docker container. So in production, does each node refer to each VM? Do we use kind in production? So we don't use kind in production. If you look at my DigitalOcean, whatever, this thing I was showing you, I have 3 nodes over here. One of them I recycled. So now I have 2, but eventually you'll see 3. These are 3 virtual machines in DigitalOcean. They are not using kind. they're running the Kubernetes code natively on the machine. So these are two old machines. This is a new recycled machine that I just created. How to scale media soup? So it's very incredibly hard, and by incredibly I mean incredibly. Like I have worked on it for a year on this specific problem statement, and still we weren't able to productionize this. So two suggestions. Like one, you can do it. It's very hard to productionize. A lot of times it's not needed. Most applications are, or most video calling applications are restricted to 300 people. A single server can handle that. Scale horizontally. You don't need a distributed media soup implementation. You can do it. That is, whatever top class or nirvana. That's where eventually this reaches. If you want to support, I don't know, million people talking to each other, but it's very difficult. And global trading applications model money management each pod would be running the auto manager for one client, but the pods can crash. So yeah, great question, right? I'm building a global trading application to give subscription based money management. Each pod would be running the order management for one client, but pods can crash. So you are right. There are a few use cases where you run one pod per user, which is what you're doing. A good example of this is Bolt. So when you open bolt.new and you start whatever, you tell it to do something, make a to-do app in React. Bolt doesn't do this, but whatever, lovable other applications, same.dev, they have, or Devin is running a server somewhere where all of this is running, right? ये सारा code एक server में भी जा रहा है. So there you need to make sure it's a new machine or a new pod. This is another use case where you have user specific pods. Can they crash? Yes. So when they crash, the front end should see a loader, the backend should re-provision a new pod, and that new pod is what should have the user's code again, or in your case, the user's orders again, and continue. Roadmap for experienced people: how to get out of the rat race, because we don't have much time to explore and learn new things. Yeah, it's like always a challenge, but yeah, I mean, you can always run your company also, is what I've learned. But if that's not happening, then you'll yourself take out time. Experienced people don't need motivation. You are smart enough to reach where you've reached, and यहाँ से just take some time out, do interesting projects that you like, and वो होते होते हो जाता है. It's very easy in the sense if you already know tech, experienced, have a backup, making some X and comfortable in tech stack, just start looking at some code bases and contribute to them. वो होते होते फिर बड़ी easily हो जाती है वो चीज़. All right. Yeah, I think it's time to open chat now. BWS, PHP, I'm good. Okay, a lot of yeah. What is super 30 capacity? Super 30 capacity would depend on the school, but mostly I don't know. Right now I don't know, but if the school has 150 people, then the super 30 capacity will be 50. If the school has 180 people, then the super 30 capacity will be 20, something like that. So I'm hope because accommodation is sort of capped there. 200 बच्चों की accommodation है अभी. So that will depend there. Where would I see bootcamp when? That's not the worst thing to do actually, because it's a good time for real-time audio. If it happens, it will not happen in media, so it's not relevant anymore. Even though I'm most comfortable in it and I'm most experienced in it, I would still do it in a live kit or something else. All right, mostly live kit or Pyan, but probably live kit only. So cool. Let's do a. I'm opening chat. Let me know if you have more questions, and we'll call it. Cool. Twitter messages and this thing. Oh, not the worst thing in the world. I think I've seen this, right? I don't know actually. Someone else, but yeah, very clean. I think I've seen this already. And yeah, how long code 3 is going to be for? Probably another 2 months, if not more. I submitted the super reviewed. No, I think you're fine. It's not the most ideal process, but again, I think 50 interviews will happen. I don't know how many have filled right now, probably 600 or I think 1,000 have filled until now. So 50 we'll be choosing based on GitHub. Then 50 में से we'll do interviews and then we'll see how many to pick. I think the number will be, so last time the number was 30 पहले, but free people don't come on site for some reason. No, it's free. So, it'll most probably be उन 50 में से whoever is ready to come on site. That number will probably be the final number for the free slots. There we go. Been a while. Do projects going to teach bare metal also? Uh, yeah. One, I know I should do projects, and two, we should do bare metal specifically on Solana. So let me see if I can find a bare metal machine and let's try to run a validator there, something like that. It makes a lot of sense to do it. The problem is no one else will be able to do it because वो machines इतनी महंगी होती है. But if there's sense to do bare metal at all, it's probably to run a validator or an RPC at the very least, and build some trading application on top of it, right? Run some code that is finding an arbitraging opportunity or liquidation opportunity in a perp, and executing it. So yeah, they're not the worst thing in the world, but I don't have experience in it, but I know people who do. So I'll talk to them and see if we can do it. I want to make a video on this as well. So over there also it'll help if we have our own RPC. एक बार और whoever is asking for selectors, just go through the video one more time. I've explained it like 4 times. Try going through it. You'll hopefully get the hang of it. But if not, just ask in the TAs after this. All right. Notion docs. Cool. Just projects. Look at one of them. Very good. As in clean. So no red flags. I guess you're the same guy because the UI looks very similar to the other one that we was looking at. Well, yeah, I think the number isn't a problem. I mean, of course, if it's 1,000 people, it'll be a problem. It was 50 the last time. I think until 150 should be manageable. But I don't know. I don't have a good answer. What are expectations to carry now? Oh, whoopsie daisy, I lost chat. Sorry, my screen keeps flickering. Wait for a second. What expectations should we carry now that you'll be busy with school and 100 people? I was pretty busy with 50 people as well. Like back then, so I live in Delhi, the office was in Noida. You're missing one very big point here. Like Super 30 is not, it's probably less involvement than the cohort from my side. It's more people being pushed to code themselves and referral opportunities. That's actually the only two big things that come out of there. Okay? And the bar is very high. Everyone is really smart. So the projects are a little high level. I don't have to go slow basically. Maybe that's why. But yeah, it's not, I wouldn't, it's not, my attention is very less generally. I probably took 20 classes throughout Super 30, right? 2 classes a week, something like that, of 2 to 3 hours. That's it. It'll be more in this one, is Super 30 mein. Because school maybe there are proper timings 11 to 6 वगैरह. There'll be more classes, more teachers, things like that. But the goal of Super 30, and that's probably the reason there should be limited supply, is people who just place themselves, like so smart people. उनको बस थोड़ा सा push कर दो, and they're not getting the opportunities. If you add them up, something comes out. They don't necessarily need to be handheld. That is the hope. That was very well executed in Super 31. We will see. One of them is OPM who got placed. Then there's other guy, again, forgot the name. There are 2 people that I know I have gotten placed recently, who I asked before I got them placed, you are going to come to Super 30 and, be with everyone. One of them is OPM, or Mihir, jiska naam hai. Who's the other guy? I forgot. Yeah, I forgot. There's like one more person who's been placed with me through us recently. Ye do hain, then 3-4 profiles I saw in the doc. I do have a package. I forgot the name for it. Google you'll find. Done. My eyes. Enhancing Oh, there we go. I was like, this looks very close to what we're making in Mobile Magic. Um, and number one, most probably direct select for Super 30. Spoke too soon. Um, all right. So what did you change? This was good. This was a good Notion doc. Running everything locally is difficult in production. We should host on our own subdomain. So, I don't know, pod ID. That's what Bolt does, or same.dev does. Is the some identifier for the pod dash some port where the application is running 3000 dot bolt dot dev, something like that. Yeah, so domain specific dependence. Yeah, exactly. Beautiful. So you should go through the code. There's a caddy file. So this is where reverse proxies come into the picture. There is this folder here called ops, which has this thing called the caddy file, which is nothing but another reverse proxy. Which, if you read through it, it says any request that comes to star.cloud.antidevs.com get parsed down to a reverse proxied to this specific thing means whatever is present over here, which is the pod ID or the service ID in this case, if you understand services in Kubernetes already. Dot user apps, which is the namespace dot svc dot cluster dot local colon 8080. So basically this is how you translate a domain name to a pod in Kubernetes. I'm still working. No, this is very good. I'll read through. I mean, let me just read through it right now because I'll forget. Let me read through everything else. I think this was done, and then I'll read through your PR. Made super DM super chats on Solana. Oh, that's good. Like a paid. So Toli is very bullish on this. He was more bullish on emails. But yeah, exactly, it's very good. He wanted this product to, so basically to apply to Colosseum with this. I'm also buying a domain workflow. Yeah, you should do it. All right, what is this? I guess this is cool. Done. And indexing platform. Oh, is this for Sol? I mean, I'm going to go through these anyways. But let's see, because I have to. Tomorrow is where I have to announce this. It's been a while since they were announced. I haven't really put the results out. But create account. Seems down right now, but happy to look at it. Wait, I'm going to review these. I don't think too many people have submitted this, honestly. Probably 2-3 people. So it'll be easy for me to know who's. If I reach your landing page, I will test it. Make sure it works though. Oh wait, you didn't have credentials over there. My bad. Sign in quickly. Okie dokie. New. Okay. NFT prices. Oh, beautiful. You have this. So yeah, NFT collection and then neon.tech. Helios. I think I was testing this the other day with someone else on the same application, and they weren't able to. That did not work. Empty tables yung yahan pe. Yeah, let's try it out on your website. Where did it go? Bro, where did it go? This one. No. There you go. Database credentials. Why can't I click on it? Something is up, dude. Sorry, this seems like a drop down. It's not opening though. ये fix कर देना भाई आज में कल. I have to test this today or tomorrow and announce the results. Something weird is happening. I hope you can see it. If I click on it, nothing is happening. So just fix this by tomorrow. Yep. All right. Keep this open. Done. All right. Where is it? Where is your PR? Let's see what you're doing. You have clear thought on what needs to be done. You have a empty Rust file. What is this? Or Rust project. What are you doing here? Oh, it's like the start Rust project. Makes sense. I would call it, Rust base image or something like that. I would probably have, whatever, some dependencies here. You have nothing like Actix Web, Tokyo, things like these. What is this? Seems like there's a lot of repeated code here in all four of these. I would change that. What are you doing here? Seems like it's just indentation you've changed, or I don't know. Yeah, it seems like have you changed anything here? Doesn't seem like it. So what did you change then? Orchestrator, indentation. Wait, what are you doing? I would assume this was already there. Indentation. Wait, this just seems like this didn't change anything. Just indentation changes. Or am I missing something, bro? Currently, okay, working on it. Adding Docker image to minimize. So I don't know if yeah, Docker image makes sense. All of these are good, but pick one and do it completely. This is good, for example. I think this was already done. Basically, you have context on what needs to be built, right? Seems based on your PR, or at least the description, you know what you're doing. So do like one part of it and show me. Seems like right now, and make sure there's no noise. There's a lot of noise in your PR right now. This, for example, it's making it hard to read. Cool. We'll call it here. Anything else? In chat. Charging. Oh, charging. It's fine. Just one more round left. Pause chat. Open this. AI based management for small startups. Oh no. I should charge. Yeah, time I have started charging. How do pod create replica set get how by replica sets get distributed among nodes? I answered that there is the scheduler running on the master, जिसका काम ही है to see कि कौन सा pod कौन से node पे जाना चाहिए. How to ensure we give unique name to selectors? Keep it very close to the application, right? How many applications are you going to have? Maybe 5, right? A backend, a front end, I don't know, Postgres database, another microservice. तो उन सबके नाम होंगे. तो just make sure app A, app B, app C, app D ऐसे चल रहा है. So you won't see too many collisions if at all. If you were given an option, pure dev or no DevOps or pure DevOps and no, I would choose pure DevOps. The reason being it's harder. It's also very chill. It also gives you a lot of power, and you can save a lot of money for the company as you do, cloud optimizations, which just sounds interesting to me right now. Is the game on ET told week 10 form 3D good game? Yeah, so the gaming tracks, I'm not super bullish on. I don't understand it very well. As in, I don't understand how to monetize them eventually. I haven't seen any crypto game do really well. So unsure what did I suggest and if it's good or not. But yeah, you should do it. Because it might be easy to. Not a lot of people would probably build games on Solana. So if you build something mediocre, you'll do well. And was able to get an offer 70% hike. Oh, beautiful. Oh, beautiful. You have a backup offer. So for after 90 days, you have somewhere to fall on. Now you have 3 months to prepare. That's the most ideal candidate for Super 30 because it's least anxiety inducing for me as well. You have another offer. You have 90 days and you can come. Not that I'm saying you'll come. Probably won't be able to because 6 months ka hai. But yes, you should do this. You should, share your whatever with me, projects with me, and we'll see. Go to Kulga HR. But congrats. Like either it's good to know. I think I saw this one. You told I come Super 30 in early in class. How can I come in touch? You told I came to Super 30 early. In class, how I came in touch? Sorry, I don't understand what this statement means. Also, if you're not able to enunciate well, It'll be really hard to explain to an interviewer as well. Alrighty. Oh, goody. Ikram has good questions usually. Ikram this side, I have a doubt on WebSockets and chats at scale. To scale WebSockets, we can use pub subs, right? Correct. So when we are multiple servers, and the user wants to send a message, or two is publish. That's correct. And on each server, it checks if the recipient correct. So my question is, would it be slow and inefficient? Suppose we have thousands of servers and millions of users, and the message will be broadcast to all servers. A server will check. So that's not true. So you've missed one thing here. The server should only subscribe to the pub sub on a specific topic if it has at least one user who's interested in it. And so you get that idea. If you have 1,000 servers, not everyone in room one is connected to one of these servers. Most probably 20 people are connected to the first server, 100 people are connected to the second server, 200 people are connected to the third server. Khatam. Baki ke servers pe room one se no one is there. And hence only room one messages need to only go to server one, server two, server three, not to everyone. So a server should only subscribe to a specific topic on the pub sub if there is at least one user interested in it. If the last user that is interested in it leaves, stop. Pub sub can become the bottleneck because of a single point of failure. So that is true. Where comes the concept of distributed or more fault tolerant, resilient pub subs? But generally, it works. Like a Redis single machine running a pub sub works. Of course, it is a single point of failure. And hence you can introduce things like a Kafka stream or something like that, or a more distributed and highly resilient pub sub. But it just works in big companies. They use it. It works. Of course, if Redis crashes someday or pub sub crashes someday, you're cool. You're screwed. So new part and then stop the old one. Correct. What if there are users on the old one? Okay, so if you have an old machine, virtual machine, where you deployed your application and you have a new virtual machine that you scaled up, whatever user was on the old one, they'll get their response right. Question really is, do they have a persistent connection to the server? If they have a WebSocket connection, then it becomes a problem. Then when you're downscaling servers or downscaling pods, you need to drain them efficiently. So if you have a stateful connection, which means there's a connection between a browser and a pod, or a browser and a node, and the node, it's a WebSocket connection, it's a long-lived connection or a long-running connection, then you can't just stop a machine. You should slowly drain it. Draining it basically means stop accepting more new connections and hope that 2 घंटे में everyone leaves. And after 2 hours, downscale the machine or stop the pod. So that's. So if it's an HTTP server, doesn't matter, right? If you're pending request from an old machine, you'll get a response from it. Great. If it's a long-running process, then it becomes a problem. It's a beautiful question in that case, and the answer is drain the pods. Most probably, people just make an assumption. Every user that's on my platform, WebSocket connection, probably like a game, or someone is on a Zerodha screen. That's when you create a WebSocket connection, right? Most probably, the user will leave in 2 hours. Like 2 घंटे से ज़्यादा कोई नहीं बैठेगा in your game. So there's an assumption that whenever a pod stops or is intended to be stopped, you actually stop it after 2 hours, but you stop taking in new requests. So that server will start to drain, and hopefully 2 hours everyone leaves. But if they don't, even in the worst case, what happens is, if there are a few people left, the server dies, the people reconnect from the client. So the client sees a small loader, trying to reconnect, and then they reconnect to a new pod or a new server in this case. Cool. Hopefully that answers your question. Alrighty, I think that's all I had today. Interesting class. Tomorrow is going to be what do you call it? Services. And before tomorrow, please have a DigitalOcean account or a Vultr account, VULTR. AWS you can have, but AWS Kubernetes setup is a little tricky. It's very hard to do using the GUI. So we have to use a CLI called EKSCTL. EKSCTL, so that's Elastic Kubernetes Service. CTL stands for whatever is the full form of CTL. What is the full form of CTL? What does CTL stand for? Command Terminal? I don't know. What is the full form of CTL? Does anyone know? What does CTL stand for in kubectl? I'm sure there are smart people here. All I see are Notion docs. Whatever. So basically, it's a CLI that does it. All right, I'll open a few more, or maybe one more. Because my screen is a little messed up right now. Browser. Oh, interested to see your other projects. I'm at least नाम से तो कुछ समझ नहीं आ रहा है, but let me see one of them. Or just tracking contest, nothing else. Yeah, pretty mid, nothing too great. But yeah, decent. At least you know what to build. Like these sound like good projects, so I would build them. And when you have them, let me know. Whenever there's an interesting challenge, which there are multiple implementations, online compiler being one, is when I'm interested to see कि आपने कैसे किया, and how someone else might do it, how Google might do it. So if you have something like this, let me know. But tracking contest is a very simple thing. You're